And again, this part here, I think actually has been covered by Björn somewhat. Wouldn't you say, Björn, that this is covered enough?
Yes, I think so. So please continue, Jess.
Yeah.
And
so I will just go to what is a batch job instead.
I think so.
Yeah. So I will look at what is a batch job and how to make a batch job. So the objective is that I will give a short intro to the Slurm scheduler, show the structure of the batch script, and then there will be some examples, some of which you will get to try yourself. So let's go on here. So say you are running programs and scripts on UPPMAX and HPC2N. If it's anything that's longer or resource intensive, or say parallel jobs or GPU jobs, you need to run it through a batch script. And that is because if you're running it on the login node, then it may be very heavy and it will take up a lot of resources. And since you are a lot of people sharing the login node, as mentioned before, then it will simply be too slow to work with if people do this. So don't run heavy stuff on the login node. And also there is generally not GPUs on the login node, and you can probably not run MPI jobs as well and things like this. So many good reasons not to do it on the login node. So the batch system at both UPPMAX and HPC2N is called Slurm. And Slurm is an open source job scheduler, and it provides three key functions. First, it keeps track of the available system resources. That is, it knows how many nodes are there, how many of them are free, how much memory is there, what GPUs are there, anything like this. And so it also enforces the local system resource usage and the job scheduling policies. So it knows how it should decide which job gets to start next. And it manages a job queue, distributes the work across resources according to the policies. And at least at HPC2N, the policies are the jobs that has, it depends partially on how long it has been since you ran a lot of stuff in your project, and also on how large a project you have. But say you have not run anything, then you have a high priority. But if you or someone in your project has run a lot, then your priority will be falling. And after a while, the priority goes up again. So it depends on how much you have run in the past, and also on, of course, what resources are available and what the priorities are of the other groups that are currently running on the system. Anyway, in order to run a batch job, you need to create and submit a Slurm submit file. And if you Google this, you will see that a Slurm submit file can also be called batch submit file, batch scripts, job scripts. There are many names for it, but they all mean the same. And there is some guides and documentation both at HPC2N and at UPPMAX about this. So let's first look at the workflow. So write a batch script, and inside the batch script, you load any modules you need, Python packages, prerequisites, activate isolated virtual environments, so you can access anything you installed yourself. And of course, and that actually should be first, you ask for resources depending on parallel jobs, serial job, GPUs, etc., etc. And then you give the commands to your Python script. So you should remember, when it's running as a batch job, you cannot interact with it. So if your Python script needs any input during the run, it has to be given in the batch script. And then at the end, when you have written it, you submit your batch script with sbatch and then the name of your batch script. It's very common to use extensions for batch scripts like .sh or .batch or .sbatch or simple or some things like that, but it's not necessary. This is mainly something people do because it makes it easier to see in your directory. So choose any names that make sense to you. A few useful commands to the batch system. You can submit jobs with sbatch and then the job script name, as I just said. To get a list of your jobs, you do sq minus u, the username. If you check on a specific job, you can use s-control show job and the job ID. And the job ID, you get that both when you submit the job, it will return a job ID, or you can get it from sq minus u, your username. It will give a list of the jobs you have that are currently running or in the queue. To delete a specific job, you do scancel and the job ID, or you can delete all your jobs with scancel minus u, your username. You can get some more useful info about a job with SACCT and some flags. It is a very, very wide output, so you pipe it, send it to the command less, which puts stuff to the screen, and then minus capital S, which does make it scrollable, which means you can look at it and use the arrow keys on your keyboard to scroll sideways in the output. If you are at Kebnekaise at HPC2N, you can create a URL to a page with info about the job with job minus usage and then the job ID. Okay, let's look at some examples. First, a serial code. And I will suggest that you try and type along. In the first one, I have a script called run_mmmult.sh, and it's matrix multiplication. And it's found in this directory for the exercises that you just downloaded or cloned. Just going to deactivate this. I'm going to go into the directory. And then I'm going to show you here, there are some subdirectory, there is exercises. I'm going to go in that. And then I'm going to go into examples. And in the examples directory, there are some other directories. There is one called programs. It contains the Python scripts. There's one called HPC2N, which contains the batch scripts for HPC2N. And then there's one for UPPMAX with the batch scripts for UPPMAX. And most of the exercises on these pages here are actually located in this directory here. Otherwise, you can simply copy it and put it into a file. So you could try open. Let's go into the UPPMAX directory like this, and I can see here. Here is the run_mmmult.sh. So I will open it with nano. And I should actually write the correct thing, of course. And as you can see here, it's the same as what is on this web page. First, this incantation-like thingy that tells the batch script that you will be using the bash shell under Linux. That's simply something you should always put there because if it's for compatibility reasons. So then you say these here commands here, #sbatch. It needs to be sbatch with capital letters. And those are all commands to the Slurm batch scheduler. So first we say there's a command here and it's -A and then the project ID. And that must always be there, so it knows which project to allocate in. And after the course, you should change to your own. And this project ID, it will be available for a few more weeks. It should be available until at least the 1st of June, so you can use it until then. After telling it what the project ID is, then you should tell it how long you want to run it. And in this case, I am saying 10 minutes. It is hours, minutes, and seconds. And the maximum is 1 week, that is 168 hours, I think. And that is the maximum of time you can ask for. Note that the longer you ask for, the longer it will probably take before your job starts, because there will be a lot of jobs waiting to start. And if you ask for a very long job, then this Slurm scheduler will be looking for a slot on a node where there is actually time for a whole week. And if, say, your job is just taking 10 minutes to run, then you don't want to sit there and wait for 3 days for several nodes to be ready for that long a time. Then just ask for 10 minutes. But another thing is, it will stop after 10 minutes if you asked for that. So make sure you ask for enough time, but not too much more. I mean, if I thought my job would run for 5 minutes, I would probably ask for 10 minutes. So something like that. And then we also tell it what resources we need. It's a serial job. We want 1 core. Then we load any modules needed. Here we need Python 3.11.8. And then we run our Python script. It doesn't take any inputs, so we just run it. And you can see at HPC2N, it's very much the same. And the only difference here is, of course, the project ID, which will be different depending on what project ID you have. And then the modules, which are different. And this is the Python code. Okay. If you look at it here, the one that is in the exercise directory, you will find that there is one more line, and that is this one, my path. And I'm using that because I have put all of this in a directory called UPPMAX, but that is not the directory I have the programs in. So I'm simply using an environment variable and setting it to where I have located all my programs. So I can easily run it from this UPPMAX directory and not having to bother about where my program files are. So I'm telling it, go look in this path. That is where I have my programs. And then I just put this path in front of all my Python scripts. And when you are doing, you're setting an environment variable here, and then you are addressing it with the $sign and the name of it, then it simply puts this stuff here in front of it. And there's one thing you need to change here, which is you can see it has the path to the storage directory, and then you need to put in your own name of your subdirectory here. For me, it is BRYDSOE. So I'm putting that. And then when I've done that, I save it, and it's nano. So I save it with Control X. This hat character that it shows in front of each of the letters means hold Control down while you press this letter. So I press Control and X. When I do that and it sees I modified something, it asks, do you want to save it? And yes, I do. And what do you want to call it? I want to keep the name. So I'm doing that. Okay, I can now submit this. And let's try see if it's running. It already ran. Let's submit it again. And then you could see here it was in state pending. It will be in pending until it starts running. I don't know if I could simply submit it a few times and see how it looks. It's probably so fast that I cannot catch it at the moment when it runs. No. So the moment I get it allocated, it runs. Okay. But it will say that it is running. R for running, where the state, and then it could be completing as well. Anyway, what I want you to see here is that unless you tell it to put it in specific named output file, it will go to one that is called slurm minus the job ID .out. And you could look in one of these files that it created with nano, for instance. And let's do that one. And then you get the content here, as you can see. So, and I could see if I can submit a few of them here, and then show this one. And when you do that, S control show and the job ID, you will see that job state is already completed. But here it could be pending, it could be running, and it will say when it started or when it's expected to start. It will tell you what nodes it ran on, directories where you have your files and where you have your submit files and everything like this. There's a lot of information in this, and you could take a look at that and also try run this one. And it's the exact same at HPC2N, as I said, with the exception that it's different modules and different project ID. And it's inside the exercise examples HPC2N directory. So they are here. And I just have a quick example for what you do when you are using a self-installed package in a virtual environment. And don't type along in this one. I will have a similar example later under the machine learning section, but this is just to show what is changed in it. So all of this here is the same, but the one thing you do is you will activate your virtual environment inside of your batch script exactly the same way as you would do in the command line with source and the path to the virtual environment. And actually it should have said /bin/activate at the end. I'm going to fix this and it should be okay in the example in the exercise directory. It's here, as you can see here. So somehow it got cut. That's one. But you source it and then you run it. Nothing different than what you would do otherwise. And another thing is you could run a Python script as a job array. And you can try this later during exercise time if you want, but it will take a little while to run, so I'm not going to do that right now. I'm just going to show you a simple way of running Python scripts with job arrays. And you do that with the command sbatch ---- array, then how many tasks you want in the array, and how many cores per task. And then you just run it and then add this environment variable slurm array task ID, so it knows which. It will create 10 of them because you asked for it up here, and then it will do this once for each of them. So And if you run the program, you will get to see how it looks and that it creates these files. So GPU code. This is a very brief GPU code, and you could try run this. There will be more under the GPU section. And if you are on UPPMAX, you will see that you are running it on Snowy. And to do that, you will say sbatch minus capital M Snowy to tell it to send it to Snowy. You will still submit it from Rackham, but you submit it to Snowy. And it's called compute py. So I am going to send this. I think it's run compute py. Let's see what it is called. Yes, this one. And if you want to see how your files are doing on Snowy, then you need to tell it that it's on Snowy. And you can see it's pending to run here. So do SQ minus U your username as before, but you need to also add minus capital M Snowy to see the status of your jobs on Snowy because you are asking for it from Rackham. It is also possible to run this interactively, and there will be more about that in a very little while. But I suggest that you try this also. Try run it. It is you can either copy it or you can use the one that is in the exercise directory. And it's the same as the one on the website, except again, I have added the path like this. So you need to change to your path, your name here. I didn't do that, so that means it has probably failed now. So let's go and change that. And now I'm doing VI, which I shouldn't, but I'm just putting in my name instead here, so it knows what path to use. Let's see if the other one finished. It did, and I'm going to show you that it complained because it didn't have a way to find the path. See, it cannot open this because I gave the wrong path. But now I fixed the path, and I can now run this here again. You can again see that it's pending. It will take a little while, and it should run now because now I actually told it the correct path to where the program is. So try those two, and there is another exercise also. And the first serial example script, sum two args here, but try to put that in instead. You know, there was this example here with mmult. So try make a similar batch script for running this instead. And remember, you need 2 arguments to the program in the batch script. And that needs to be given in the batch script, of course. The solutions are given here. It's also on the exercise section, but try to look at it yourself first. So key points. The Slurm scheduler handles allocations to the calculation nodes. The interactive sessions will be presented in the next section. It has been moved around since last time we did this. Batch jobs run without interaction with user. Batch scripts consists of one part with Slurm parameters describing allocations and which resources to use, and a second part describing actual work and loading modules, for instance, one or several Python scripts. Remember, include input parameters to Python scripts in the batch script because it's not interactively if it's an actual batch script. So let's see if this ran. It's still pending. Okay. I'm going to stop my share.